geometric operations vectors. So in this lesson, we're going to talk about how to use vectors in like geometry and like real space. We're going to talk about adding and subtracting vectors using the actual components of a vector. So our first example here, right? Suppose you have three towns, P, Q, R. You want to start at P, and you want to make a trip to Q, and then from Q you want to go to R. Well, if you add that path there, you end up with PR. You can see if you use the two vector components. So like first you did PQ. This is vector PQ. And then we're adding in vector QR. So you can kind of see it right here, right? PQ plus QR. What happens is it's kind of like the transitive property. If you're adding PQ plus QR, see how these two things match? Well, you end up with this getting the edges, PR. And then you added those two vectors. And that's always true. If I add AB with BE, I'm going to get the vector AE. So vector addition works that way. If you have the labels, you can just go, okay, AB plus BE, you're going to get AE. And it works the same way geometrically. No matter how you draw PQ plus QR, you always end up with PR. Even if it's small, if it's big, PQ plus QR, you always end up with PR. Let's talk about how to actually physically add vectors. So if you want to construct vector A plus vector B, well, first you draw A, and then at the arrow end, you draw B. So what does that mean? I always say adding vectors is you add tip to tail. That's how we add vectors. So if I give you a vector A here, and a vector B here, if you want to add them, you're going to add the tip of the first one. That's my tip. To the tail of the second one. So here's, so it helps you, that's the tail. So you're going to add the tail of that one to the end right here, just to kind of connect it. So you added the tip, so you're adding the tip of the first vector to the tail of the second vector. And then the resultant is just connect them from here to there. That's A plus B. So it's all about adding A to B. Tip to tail. Is what I meant to say. It's all about adding tip to tail. So let's look at an example here. They want me to add A plus B. So again, same idea, right? A is there. I want to add B to it. So I'm going to add the tip of A to the tail of B. So I'm going to move this B to like right there. So I'm going to try my best to get this exact. So something like that. Right? So A, I moved B right there to the very end of it. Tip to tail. And then the resultant is connect where you started to where you ended. Tip to tail. Right? And that's the key to adding vectors. It's all about adding tip to tail. So again, I could give you a vector like C. I got it to vector D. All you can do is add tip to tail. So C looks like this. We're going to move D over. Put it right there. And then your resultant vector is this one, where you started tip, tail, to the tip. C plus D. Right, so that's how you add vectors. It's all about tip to tail. And then you just go from where you started to where you ended to get the resultant vector. How about a zero vector? Well, a zero vector does this. This is 0 to vector length 0. So much like numbers, when you add 0 to a vector, you just get the vector back. So that's all you see here. If you add a vector to its negative, so remember what a negative vector is? That's a vector going in the wrong direction, like that. And then a negative A would be going the opposite direction. If I wanted to add those two vectors up, you'd be going this way. And then to the tail of it, you have to the tip of it, you have the tail of this guy, which will be going back again. And you end up right where you started. So you end up with 0. So, 0 vector pretty much just works like a normal number. 0 is 0. So this is what's going on here. They want us to add these vectors up. Let's see what we get. So look at this one. BC plus BA plus CA. Well, the middle two connect, so we just get BA. But you can also see it on here. If I add BC, that's starting at B, going to C, and then I add CA, so now we're at C, we can go to A. Right, so I had let me draw a little nicer. So we went like this, and then we went CA. What's my resultant vector? Well, I started at B going toward A. BA. Right, so start at B, go to C, then you go from C to A. What's left over? Well, I started at B and ended at A, so BA. So it works that way too. Look at the next one. BA plus AE plus EA. Well, notice how these all connect? So I should get BC. So let's erase that so we can try it. Right, so again, right, notice how these connect, so same rule applies. I go from B all the way to C. As long as I'm adding and all the middle two terms connect. Let's actually try it on here. So BA, starting at B, going toward A. Then I go A to E, so starting at A and going toward E. And then going E to C. So starting at E, going towards C. And then again, what you end up is with your resultant vector. Where did you start? I started at B, and where did I end? At C. So I'll be the vector BC. The next one, same idea. AB plus BC. So in this case, I'll get AA, which is just a 0 vector. So let's look at it, so you can see what I mean. Didn't erase too well. Okay, so I'm starting at A and going toward B. Then we start at B, go towards C. Then we start at C and go toward A. You end up right back where you started, or 0. You didn't move at all. And then the next one, AB plus BC plus CD equals D. If you see again, these connect, these connect, these connect, and you're just gonna end up with AE. You could prove that yourself right here. How do you subtract vectors? We know how to add them. How about subtraction? Well, here's the secret about mathematics. There's no such thing as subtraction. When you subtract numbers, all you're really doing is adding the negative. That's all subtraction is. It's the same thing with vectors. If I want you to subtract a vector, all you're going to do is add the negative of that vector. Right, so like right here, they showed an example. If you have A and B, if I want to subtract B from A minus B, well, all I'm going to do is add the negative of B, right? Negative B would be B would go in the opposite direction. That is negative B. So I'm just going to add that to the end of A. So you can see here, A plus negative B would get me A minus B. Probably like this, which is written as A minus B. So that's how you subtract vectors, just like subtract numbers. All you're going to do is add the negatives. So some quick examples. R minus S, or the way I like to think about it, R plus negative S. So here's R, here's S. So to do A, I'm going to get my R, and I'm going to add negative S to it. So I'm going to flip S around and add it to the tip of the tail, which is right here. So it's going to be like kind of like this. Right, that'll be negative S. And then my answer will be, I started here, ended there, R minus S. Or R plus negative S if you prefer. How about B? Well, S minus T minus R, or S plus negative T plus negative R is the way I would see it. So S plus negative T plus negative R. So S is going this way roughly. I'm going to add negative T, so going the opposite way. So kind of like this. Oh, that's not the best negative T. And then negative R, so go in the opposite direction. So start here and go in this way, roughly. And then from where you started to where you ended. That right there is roughly, very rough, S minus T minus R. Right, so that line right there. So that's how you subtract vectors, just add the negative. And the same works with when you're working with just the labels. There's really no subtraction, but there is adding negatives. But there's one key point here. If we talked about this in an earlier video. Negatives with these guys, like if I give you CB, the negative of that just flips the letters. So the negative CB is, or CB should I say, is negative BC. So I guess likewise, if you have like negative AB, that'll just be positive BA. So that's how it works with letters. So if like right here, I have negative CB. If I want to, I could write that as positive BC. And if I add it to AB, I hope you notice, hey, these two things match, so I just get AC. I can do the same thing here. AC, that's a negative, I can flip it to a positive CB. And the same thing here, I can flip that to a positive BD. And now if you notice, these all connect. C connects with C, B connects with D, and I just get AD. Alright, so again, it does work both ways. If I give you AB, let's say minus CB, if you want to, you can just rewrite this as negative BC, but there's a negative in front, so that becomes AB plus BC. So it works either way. Right, you can do it like that, or you could do it just like, oh, I see a negative, switch it to a positive. With that in mind, they want you to construct vector equations using this. So there's lots of ways to do this. If you start like normally, like find two that connect, that's what I would do. If I look at R here, I start at R, then I connect that to S. So R plus S would equal T. If you try to get more fancy, you can always look at a negative version of this. Let's say I flip T. So I get negative T. Now what connects? Well, if I start at R, I start at S, sorry. S plus negative T would get me R. So it'd start here, now it'd end there. Actually, S plus negative T would give me negative R. Right, so start here. I'll go from here to there, so it's the opposite of R. So you can do the same thing here. Again, any way you want to do it, you want to start here. If I go down this path, I get P, and then I just follow this path. I get P plus R, and I ended up with Q. We'll do more of that in a second. Like here. They want me to find RS and T. They want me to find all of these in terms of RS and T. So that means I can only use the vectors RS and T, nothing else. So they want me to start at R and go to S. A little confusing with the double R and double S, but they mean capital R, capital S. So they mean start here and end there. Well, how would I do that? Well, I have to start at R. I have no vector going this way, so I have to go this way, because I can only use the vectors I have. Right, so I'm starting at R, I have to use this vector. Now I'm going to go the opposite way. So it's going to be like negative R. Then I want to go up to S. Well, look at these two. My negative R and my S, they connect perfectly. Like, let me draw it down here. Right, they connect tip to tail. And what do I end up with? The thing that goes from here to there, which is capital R to capital S. So, well, it's another way to write that is negative R plus S, right? So if I start at R, I have to go down negative R, and then I have to go up S the proper way. So negative R plus S. Let's do that a couple more times. So then it's always a little weird the first time you see it. So let's look at SR. Let me erase a little better. So I'm going to start at S, and I'm going to go to R. I'm going to go the opposite way. Not as exciting as I thought it was going to be. Well, kind of the same idea. So if you're going to start at S, you got to go down this way. Because again, you only go down one of these letters here, the ones that we have. So I go down this way. Essentially, I got to go opposite S. So that's being negative S. And then I could just go up R. It's going the proper way now. Tip to tail. So negative S plus R, right? Start at S. I go against small lowercase s, which makes it negative S I'm doing. And then I'm going up R. So negative S plus R. How about ST? So they want me to start at S and go towards T. So same idea. So if you're starting at S, you can only go down one path. That's opposite S. So I have to go the opposite of this way. So it's negative S. Then I'm going to go toward T. Well, T's going the right direction, right? They connect tip to tail here. Like the arrow's pointing the direction I'm trying to go. So that's a positive T. So you decided negative S plus T. Or T minus S if you want. Either way is fine. It's about scalar multiplication. If you remember from before, scalar just means a number. It's how long is your vector. So that's all a scalar is. So if you want to do scalar multiplication, you just multiply by a number. So if you see here, a, if I want to figure out what 2a is, it's just 2 times a, or a plus a. If you add a plus a, you get 2a. So you just draw 2 a's. That's 2a. You want 3a? Funny idea. Draw 3 a's all connected. Right? That's 3 times the size of a. So the length of this guy is a. That's the length of 3a. If I wanted negative 3a, well, remember, all the negative does is go the opposite direction. So 3a going the wrong way. So in general, 2a is the same direction as a, but going twice as long. 3a is the same direction as a, but going 3 times as long. And negative 3a is the opposite direction, but just as long as a. 3a's. In general, when you multiply by a number, you get the same direction. If you multiply by a negative, you get the opposite direction. If you multiply by 0, just like numbers, you get 0. Right? So same rules apply for normal mathematics. So let's do some of these. They want 2r plus s. So again, 2r means I want 2 of these r's. So let's say that's 1r. And that's another r. That's my 2r. I want to add s to the end of it. So we're just going to add tip to tail. So I'm going to add this s to the end of it. So it's kind of like this. There's my s, my approximation. So my answer is going to be from where I started to where I ended. This blue line here is 2r plus s. How about r minus s? Now remember, we don't really subtract. I see this as r plus negative 3s. So 3s is going the wrong direction. So let's do r first. So r is going like this. Now we need negative 3s's. S is going this way, so negative s would be going the opposite way. I need 3 of those. So negative s, and negative s. Negative 3s. And then the answer is just going to be from where I started to where I ended. That's roughly r minus 3s. So again, your answer is that actual arrow you found there. So like, this is my answer, this is my answer. It's the resultant vector is your answer. Let's see this. Sketch vectors p and q if p is 3q. So they're just saying, hey, p is 3q. So it always works with me. So let's say we have 3q. So here's q, and let's draw 3 of them. That says, and they want p to be equal to that. So p must be like a long vector, like that. So that'll be my p, and that'll be a little thing with my q. How about this one? P equals 1/2 q. So I always try to draw that first. So let's just give a q. Let's say q is, I don't know, this. What is negative 1/2 q? Well, it'll be go in the wrong direction, but only half as big. Something to that effect. So that must be my p. So when you do this problem, the easiest way to do it is just pick a generic q, and then do this to it, and that becomes your p. Same thing I did here, right? I picked a generic q, this guy, and I was like, okay, let me do this to it. So I added 3 of them, and that's my p. That's it.